My name is Marc Bozarth, Penn State Workforce Education 105, lesson number 8. What I want to talk about today is something that's virtually everywhere that most people find intriguing, if not fascinating, and that's welding. It involves almost every product you touch in your home, outside your home. And when I say people find it intriguing or fascinating, I'll give you an example. So you're working on your vehicle or you're mowing your yard, some activity like that. Somebody walks up and they're watching you. You say, oh, would you like to try this? Oh, no thanks. No, I don't want to try that. But if you're welding and somebody comes up and they're watching you weld and you say, would you like to try this? Oh yeah, I want to do that. And there's something about it. People watch a person weld and they think it's simple, there's nothing to it, it's as simple as taking a pencil and drawing a line. And what I want to talk about today will show you that there's more planning involved, there's a lot more knowledge and skill than people realize. Now, first off, we'll talk a little bit about safety. As any activity or work, you want to make sure that you are safe and look at the hazards and preventative measures for those. Some of the hazards involved in any type of electric arc welding, number one is electric shock. And whenever you're welding, your number one priority is not to become part of the circuit. So in order to prevent the shock, you want to make sure that you use your PPE. Some of the other obvious hazards are burns from the hot metal, the arc itself, and also some of the things that are not obvious, burns from the different types of radiation that's emitted from the welding processes. An example of that is like your UV rays can create, you may have heard welder's tan, it's like a sunburn, and also burn your eyes. Now, arc burn on the eyes is very unpleasant. It feels like somebody has placed 2 handfuls of sand in your eyes. Uncomfortable, and I don't recommend it, so you want to avoid that at all costs. Your PPE, personal protective equipment, first of all, some type of a jacket, depending on the type of your welding you're doing, the process, and that sort of thing. Doing a lot of heavy welding, you get a lot of heavy spatter and rollers, hot rollers, and molten pieces of metal coming out. Probably a leather coat recommended. Different types. The jacket I have on, the body is a treated cotton material, flame retardant treating with leather sleeves. And this is adequate for a lot of type of welding. You also want to make sure you have a good pair of gloves. These are a gauntlet style. Comes up the arm, protects you there. Make sure your gloves are dry. If you're doing a process like shielded metal arc welding and you have wet gloves and you strike an arc, you'll get a pretty good jolt. I don't recommend that either. It's uncomfortable. One of the other things is a good quality welding helmet with a proper shade of lens. Usually from a shade 9 to 14, the higher the number, the darker the shade. You want to make sure you select the proper one for application for what you're doing. The higher the amperage in different processes, you want a darker shade to protect your eyes. Also recommended is a good pair of safety glasses, even though you have the helmet covering your face and everything. Just in case something gets past that, you want to make sure you protect your eyes. Something you may not think about, earplugs. This is a foam type. You roll it, compress it, insert it in the ear canal, and it expands. Not only from the noise that's emitted from different processes, but also some of the sparks and hot rollers. Now, I had a friend that was welding in a shipyard, and there was a bulkhead close by, and one of the hot rollers, a piece of molten metal, hit the wall, bounced off, went into his ear, and he said he could hear it as it came down the ear canal, went all the way down, and then burned through and pierced his eardrum. Quite painful. So you want to make sure you protect yourself. I would be careful as far as trying to block out all the noise, because one of the things that you do in your welding is listen to your welder or the sound of the weld itself. And it's like the proper settings, and just block out enough noise to protect the ear and protect you from the sparks. The equipment. Now, when I mentioned different processes of welding, what I meant by that, I'll give you an example, GMAW, and that is gas metal arc welding. The wire processes, they're GTAW, gas tungsten arc welding. You may have heard it called TIG, or years ago, heliarc. What we're going to use for this particular exercise today is a simple form, the oldest form of electric arc welding, and that's SMAW, or shielded metal arc welding, also commonly known as stick welding. Simple, basic equipment. You're going to have your welding machine, your power source, and then you'll have what's commonly called in the field a stinger. Proper term for this is electrode holder. Also in the field, this is called the ground. It's really not a ground. The proper term for this is work cable or work. Make sure you have a good solid connection on what you're welding on to also produce a good quality weld, but to prevent electric shock as well with that. And the electrode itself. And you see this is a 7018 electrode. That's the type of electrode, low hydrogen. Now, some of the things you need to know in order to produce a good quality weld. Number one is the metal itself. What are you going to weld on? Well, I have a piece of metal. What type of metal is it? You're going to have to determine, is it ferrous, which means contains iron, or non-ferrous, which doesn't contain iron. An example would be stainless steel, something like that. Also, you're going to look at the thickness of your material and the condition of the material. That helps you determine what type of electrode, the amperage, the setting amperage or voltage on your welding machine, and the polarity. When I say polarity, an example is electrode positive, electrode negative. Some of the information on your electrode, you'll find the electrode manufacturers, the companies put out booklets like this, and they like people to have them because it's also a catalog. It has their products in it. You can pick them up free at a welding store, or nowadays everybody has a smartphone, so you can go online to that particular manufacturer's website and you can get all the information for the electrode you're using there as well. Also, I mentioned the condition of the metal. If it's a rusty metal, something like this low hydrogen rod is not going to work. It requires a nice clean metal. If you have metal with rust, or it's dirty or greasy, then you probably want to use a 60 series, something like a 6010, 6011, 6013. It goes through that rust and the dirt, the grease, and gets good penetration. So that's another factor in determining what type of electrode you're going to use. Then we have to look at position. Are you welding flat? Is it horizontal, a vertical weld, or overhead? That also determines the type of electrode you're going to use. Also, the position of your body. In order to get a good quality weld, you want to be as steady and comfortable as you can possibly get. Now, I see guys come in and they do the macho, they're going to do a one-hand weld and everything. I don't recommend that. I've been welding for 42 years, and I'll tell you, when I set up to make a weld, I'm going to find something to rest on. I'm going to get as comfortable as I can possibly get. I'm going to take my free hand and try to steady and brace the hand that's holding the electrode holder, and be able to get a good quality weld that way. Also, vision. You want to be able to be in a position where you can see the arc length, the tip of that electrode, and the puddle. Your objective is to control that puddle. You can't do it if you can't see it. So those are some of the things you need to think about as far as your position. Another thing, the electrode and the electrode holder, travel angle. Now, if I'm welding from left to right, I set like this, this is the travel angle right here. I like to have my travel angle somewhere between 5 and 15 degrees. So as I strike the arc and I begin to move across, I'll have it like that. Now there's another angle. Let's say I'm going to make a fillet weld on this T. I have my travel angle, which is this way, okay, but I also need to consider my work angle, which would be this angle like this. So you have two different angles that you're going to have to watch and control. The other thing is your travel speed, the rate you deposit, the deposition of the material in the electrode. and the arc length, which is the distance from the tip of the electrode to your workpiece, your metal. Generally speaking, you want the arc length to be the diameter of your electrode. Now, when I say the diameter of the electrode, I'm talking about the metal portion, that's the wire here, not the flux coating. So this particular piece right here is an 1/8 inch, so I want my arc length to be an 1/8 inch long. And that controls the penetration and how much material you're actually depositing in that. If you have your arc length too long, you're not going to get penetration. It's going to build up, and the wall's going to become too high. Arc gets erratic, and a lot of bad things happen. So you want to watch that. Also, the feed rate. So as you're welding, this electrode is being consumed. It's burning off, so you want to make sure you feed it in to maintain that arc length. So you have to think of all those different things. You got a travel angle, a work angle, the arc length, your travel speed, the feed rate, all those things you're doing at once. So when people look at arc welding or any form of welding and think it's simple, it really isn't. There's a lot more to it. We have people that walk into our shop and they have an idea that they're going to come in and probably 2 or 3 hours they're going to walk out with a welding certification, and it's not going to happen.